Welcome to Project Iceberg. I am here in New York City to visit Vanessa, one of the 6 science educators I will be traveling with to Antarctica in just a few weeks.
Hi, I'm Vanessa Miller from New York City, and we're here at Central Park East 2 in East Harlem with my 4th and 5th grade class, and I'm going to Antarctica.
Vanessa and I are getting ready to join the ANDRILL scientists and other science educators in Antarctica, where we will study the rocks beneath all of the ice. From these rocks, scientists can look for clues about Earth's history. These clues will help determine patterns of how our planet has changed through time. These patterns will also help scientists predict what the future may look like here on Earth.
Hi, I'm Richard Levy and I'm a geologist. I'm particularly interested in studying rocks in Antarctica, but it's a bit of a challenge to get to those rocks because they're covered by ice. So when we want to do geology in Antarctica, we first have to figure out ways to get to the rock that's hidden beneath this thick blanket of ice.
We asked Vanessa's students how they would face this challenge. Remember that ANDRILL geoscientists want to study the rock beneath the ice. To get there, we must first get through 1.5 football fields worth of ice, and then through enough water to flood 2.5 Empire State Buildings. And from there, we need to bring up 1,200 meters of rock core, which is enough to stretch across 13 football fields.
So first, I would drill through the ice like that, and then I would swim through the water because I had that big oxygen tank. And then I would go down, then I would drill a piece of rock, and then I would take a bucket and put the rock in the bucket and swim up again, and then I would drill up through the ice again, and then I would have everything.
I use the shovel to spin it, and it'll make a big hole, and then you get into the water, you get a tank and then swim, and then take out the rocks.
In a challenge like this, remember that there are no right or wrong answers. Scientists around the world have discussed possible solutions for decades and have tested many of their ideas.
Engineers from the ANDRILL program have developed a special tool, a tool that uses hot water to melt its way through the ice. It's really pretty cool. We can then lower a drill string or a drill pipe down through the ice into the water column, all the way down to the seafloor, some 900 meters below. Once the drill pipe reaches the seafloor, we start to turn it round and round and round, and it cores down into the seafloor. And we pull out of the ground a piece of rock that kind of looks like this, a round tube. But this tube's going to be about 1.2 kilometers long when we're finished.
The drill head connects to the drill pipe, rotating it downwards. When the pipes need to be retrieved from the hole, they are pulled back up and clamped so long sections of it can be unscrewed from the pipe. It takes about 3/4 of an hour to pull out the core barrel, which brings up the actual rock core. After the drillers have pulled up the first ANDRILL core, the scientists immediately begin to examine the rock. They discuss, take notes, and hypothesize about what they first see. Vanessa works with the sedimentologists to create smear slides, which are constructed by taking a small sample of the core, smearing it onto a cover slip, mixing it with distilled water, and drying it with optical adhesive. These smear slides then go to Rob and other scientists who examine the tiny details to gain new perspectives of the larger story. As more core is pulled from the ground in the coming weeks, the scientists will work as a team to put together a coherent story that represents this piece of Antarctica's past.